Okay, so let's come back to our discussion. So, so what is if now we know the computer and how it works? It requires data, okay, and not only data but also the sequence to execute those data. So, which one must be added first? And what next after addition? What next? Is it multiplication, subtract, or others? So computer requires both of them. Data, input data, and the sequence of the instruction. Okay. So this set of instructions that tell the computer what to do, we call this as a program. And this program is designed using a logical thinking. So for example, if you want to go to your girlfriend's house, your girlfriend's home, then you have to think uh, what time you have to go out from your home and what kind of thing you should bring to make the parents of your girlfriend uh, becomes nice to you. Okay, then what kind of dress you should wear, something like this. Has a sequence. It has sequence and uh, have different tasks at every sequence. That's what we call algorithm. The logic, the logic flow to achieve the output or the result. Okay, the result is that you will arrive at your girlfriend home, and the family will how to say, will welcome you nicely. So that the same way goes with computer and program. So therefore, the logic thinking is very important here. And during this, the first half semester, we will uh, have a lot of practice about this logical thinking, or we call algorithm. And about the program, we have here uh, the the example of code, programming code of Python. Okay. While we use Python or C or any other language program such as Fortran, Visual Basic, Delphi, and other language, because we need to communicate with computer. Computer only understand one and zero, but we don't know this. We don't understand about one and zero. What we understand is our language, human language. Okay? So this uh, programming language interpret or translate our language into machine language, into binary code, so that the computer understands what we input there. So that's the main function of uh, the programming language, okay, to convert our language into machine language. And to use this uh, this computer language, this programming language, we have to follow their rules. that we call syntax. It's kind of the rule how we write our logic using that language so that it can be understood by the computer. If we don't follow the syntax, so there is an error in our program. There will be error in our program. Okay, but syntax error is easily to be solved. Okay, if we have an error writing this code, then computer or this language, this programming language can point us in which row we made a mistake and what kind of mistake and how to repair that code, how to revise that code. There is suggestion. Okay? So syntax error can be easily handled by the programming language. But if the error is in our logic thinking, then the program still work, computer understand, but we get the result is out of expectation. I mean, we get the wrong result. If we enter 5 and by 3, it should be 8. But because we have the not syntax, because we have the logic error, the algorithm error, then we cannot obtain 8. But otherwise, instead of 8, we get number of 10 or 0 or any other numbers. And this kind of error more difficult to solve, and the programming language cannot help us with this kind of error because they cannot detect the error, because the error is not how to use the language but how we think. Okay, the error is in our head, not in the language program. So we have to find it in our logic. Okay. So therefore, it is very helpful to write the sequence of instruction as an algorithm using flowchart, using step statement or other method, which can give us a set of instruction in sequence. Okay. So there are many programming language here, but we will use Python. We will use Python for our class. Why? Because actually for exercise to develop the algorithm, Python is not the best, programming language. Maybe we can use Pascal or C++, where we have to define everything in our program. But, in that way, we can develop our logical thinking better. But using MATLAB or Python, there are a lot of available function there. So we just pick one of them which is appropriate to be used for our project. So for example, to sort the number from minimum to maximum, we need not to make a long programming code using Python, because we just call the function of sorting, data sorting, then the problem finished. Python will do everything for us, will handle everything for us. We just give the data input and give the command sorting the data, then finish. We get the sorted the list of the sorted number from minimum to maximum or vice versa. Yeah, but in Pascal and in C++, we have to define the logic, how we compare each number so that we can arrange them from the minimum to the maximum value. But that's the disadvantage of Python. Okay, but it is also good advantage for us because we don't need to think about the detail. Okay, we just think about the big picture of our project, and for the detail function, it is already prepared by Python. So we just use that function in our project, then finish. So in that way, we can increase our productivity because we are an engineer, not how to say, not a computer not a computer engineer. We are mechanical engineer. So we just use what prepared by the computer engineer for us. Okay, just like in the design of mechanical object, we don't need to derive the equation of Taylor number or Taylor series. We just take them from the mathematicians and use them to solve our problem. So because of those reasons, we choose to use Python here to simplify the programming code and focus on the main function or the main purpose, that is to help us to solve the engineering problem. Okay, and so this slide gives us the overall illustration of the previous discussion. So first we have engineering problem. Okay, then we make a strategy to solve this problem. Usually the calculation is similar, so we will repeat this calculation. So in order to be done automatically, so we make a set of instructions for computer to do the computation automatically. So the first step, you must calculate this, and the next step, you have to divide by this, and so on. Then we draw this algorithm in the flowchart. Why we choose flowchart? Because flowchart easily can be easily interpreted, because we know the loop when we have to come back to the previous step, and at which step we have to stop, and so on. So we will use flowchart to define our algorithm. Then we will make the code based on this flowchart. Then we will check the result of our program, whether it is valid or not. It gives us the result as expected or not. Okay. So this is another illustration about algorithm. So algorithm is well-defined instruction. Okay, from its input to have an output. And this is a good example of algorithm. So when you find that your room become dark because the lamp doesn't work, then what you need to do? You have to check whether the lamp is plugged in or not. Is there any electricity or not? So if no, then plug in the lamp. Okay, but if the lamp is already plugged in but still doesn't work, then maybe there is a problem with the lamp itself. So you have to check if the bulb burn out. So if burn out, then you have to replace the bulb. But if no, then you have to uh, buy the new lamp. So that's a sequence of uh, how to replace the lamp. And another more specific example of algorithm is the parking area. Okay. So in the entrance gate, the driver cannot go inside the parking area because the entrance gate is closed. And in the entrance gate, there is an information whether the entrance gate is full or not. So how we can get the information in real time, okay, automatically. So first entrance gate is closed, and is a car at and the gate detect whether there is a car or not in front of the entrance gate. If no, the gate still closed. But if there is a car arrived and detected by the gate, then the gate will check, will calculate if the parking area full or not. So we have to define the number. If the capacity is 10, then the gate must check if the number of cars inside the parking area still less than 1. If still less than 10, if less than 10, then the entrance gate open. But if they found that the parking area already full or the number of cars equal with 10, then the gate still closed and there is a message for the driver to inform that the parking area still full. So this is also need algorithm. This kind of automatic system also requires algorithm. Okay. So the same way goes with our computer program. Okay. And we have the characteristic of good algorithm. First, input and output should be defined precisely. So what we want to get and what kind of information that must be entered. So, for example, if you want to have a program for calculation which accommodate addition and subtraction, then we have to define the input. So we need more than one input in order can be added each other. Okay. But if only single input, then it will not work properly. So what kind of input? It must be numbered. Because in our keyboard we have letter also. So if accidentally the user input the letter, not the number, then the program must must send the message to the user. You have to revise your input data. It must be the number. So good algorithm only process uh, the correct data and give the result also in correct number. Input and output must be defined precisely. So for example here, for the addition of two numbers, we have the requirement of input and output at step number 2, declare variable number. So what kind of number? Okay, we can differentiate between number and letter. So next, what kind of number? Because there are many numbers we have. We have decimal, we have hexadecimal, we have binary number, okay, and many format number. So what type of number that we use? It must be declared clearly. Okay. Then next, the second requirement for good algorithm is each step must be clear. Okay. Must be clear. So we have a simple example here for addition of two numbers. So after declare the variable and read the input from the user, then next step 4, we have addition operation. So for this addition, we have to sum which number, okay? Then display the result, then stop. Because it is very simple calculation, then we can use this, and this is already clear for addition function. Okay. So declare the type of variable and read the number and do the addition, then display the result, then stop and finish. Okay. But for a real problem in engineering, we not just add two numbers, but we calculate many numbers using many formula. And the calculation always change in each sequence, at each step. Okay. First, we have to calculate the angle, then convert it into radians, and then calculate the response of vibration, and so on. And if we found that the calculation less than one parameter, then we have to go back to the previous calculation and change something. So each step must be declared clearly and only have one interpretation. Okay, only have one interpretation. So the computer or programming language will not confuse to interpret our logic, our algorithm. So algorithm also should be most effective among many different ways to solve a problem. So to solve the problem, singular problem, maybe we have several strategies or several options to solve this problem. And after we list the option of the problem solving, then we have to choose the most effective method. Okay, in that way we can cut the computational time and also the requirement for the hardware. So we call this algorithm optimization. But we will not doing this for this course because we still in basic. Okay, we try to make a good algorithm, but to optimize this algorithm, it is another discipline, okay, another course. So that's the third characteristic of good algorithm. Among many methods, we have to choose which one is fastest and the most efficient for calculation. Okay. And for algorithm, because this is our language, we must avoid to use the computer code because we will use this algorithm to discuss with another programmer. So it depends on what kind of program they will use. If we have different programming language, then if we put the programming language in our algorithm, it will make other people confused. Only we can understand our algorithm, but other people will not understand because they use different programming language. So that's why please avoid to put the programming code in the algorithm. Algorithm must be in our language. Okay. The description at each step of algorithm must be in our language. Okay, so this is example for good algorithm. So how to sort this number, uh, the top list number. We have here 1, 2, 3, 4, 5, 6, 7 cells with different number. So how to sort this number from the minimum into maximum? The first strategy that appear in our head is by comparing them one by one. 38 compared by 27. 38 is larger than 27. Then we have to move the number 38 behind the 27. Then compare again this number with 43 number. And because it is lower, then it's still in its original position. Then we go to the next cell. If we do this kind of method or algorithm, we will repeat the same the same job or the same how to say we do the comparison double. So sometimes we found that 38 is larger than 27. Then if we go on this method and we go to the number 3, then we compare again, go back to the front cell, and it is required a lot of time and a lot of calculation. So instead of comparing this number individually, then we can split up this this array of number into two rooms or two groups. So because we have 7 cells here, then we split up into two groups. The first contain 4 cells and the second contain 3 cells. Then we can split up again until it contains only 2 numbers or 1 number only. Okay, then we can compare between these 2 cells. So for example, 38 and 27 compare. So we have 27 is lower than 38. Then we move the sequence of this number. Okay. And then go to the next group. We compare 43 with 3. Then we know that 3 is lower than 43. Then change the position. So by split up the number into smaller group, then we can rearrange the number from minimum to maximum faster. Okay, if it contains only 7 number, then we can do it manually faster than computer maybe. Okay, But for large or bigger data, then maybe we cannot handle this kind of calculation. Okay, so computer will handle this with the appropriate algorithm. So is there any question about this one, about the algorithm? Is there anything that can be discussed here?
I want to ask, sir.
Yes, for sure, Bagas.
Uh, you know uh when a engineer is using an algorithm to solve some problem, maybe they didn't think one of the problem, or maybe they miss one of the problem, so the algorithm isn't perfect. So how to troubleshoot that situation, sir?
Yes, first, because we don't know the problem is, just finish the algorithm and try this algorithm. Okay, then see the result. And uh, for your information, in semester 6 or 5, you will learn about the numerical analysis. So in numerical analysis, there are a lot of engineering problems solved numerically using algorithm, using formula and algorithm. So the best way, I think, in my experience, is to see whether our algorithm is already complete or not, or uh, can give us the expected result or not, is by make a validation. So check. So usually we compare our calculation with experiments. So now in our lab, me with several students try to make a model of adhesive joint for lightweight structure. Okay, using adhesive. So using adhesive, we can join different lightweight materials such as carbon fiber with aluminum, or carbon fiber with ceramic and others. Okay, so we will model this joint using computer and calculate the stress and deformation in this joint. So to check the best way to check if our calculation, if our model, if our algorithm already appropriate or not, is by comparing with the experimental result. So that's why we have instrument uh, to to test our joint, our adhesive joint. So we have tensile test, and in our laboratory we have split Hopkinson pressure bar test, which test joint with the impact load. Okay, and comparing with our model. So if we found that there is large deviation or large difference between the result of experiment data and our calculation, then our calculation or our model maybe contain some error. Okay, then it is very challenging to solve. It is not always easy to solve this kind of problem, but usually we go back to the basic, such as if we take appropriate assumption or not in our modeling, because in the model we have to make simplification, such as geometry simplification, material model simplification. So if we consider the adhesive as isotropic material, then is it appropriate or not? Or we have to change to not isotropic, but orthotropic material or something like that. So it's kind of an iteration, Bagas. That's
Okay,
very good
okay.
question. Hmm.
So uh, if I can summarize it, is we use simulation
Hmm.
to trial and error to fix the algorithm, right?
Yes.
Okay,
Well,
okay.
not trial
I
and
see, I
error,
see.
but experiment.
Oh
Trial,
yeah, yeah, yeah.
there is a big difference between trial and error with experiment. Using trial and error, you try something without controlling the, the parameter which affect the result. But by experiment, you make a control environment, control parameter, and only one can be changed. So you can make sure that if the result change because we change this variable, that experiment. But trial error, you do something and then just if anything goes wrong, then there is must be failure, but you cannot identify. Okay, so I love this question, Bagas, because as you can see in the very beginning illustration here, this is actually our project with Pupuk Kalimantan Timur (PKT). So they have problem for the actuator shaft in their boiler. So the temperature is about 400 degree. Okay, so it will affect the behavior of material. We cannot model our object here using linear material or linear deformation. And also we cannot use the tensile test data because it doesn't contain the effect of temperature. So here we have to revise our model many many times and compare with the data obtained by PT Kalimantan Timur, PKT, Pupuk Kalimantan Timur. So uh, actually, this is what we do in our laboratory as a project with industry. And who did this simulation? Uh, this simulation done by students uh, which just finished the the class of programming language, just like you. So after finish the class or at the end of the semester, I choose several students to join in our project because I can measure their competency in the programming language or in the algorithm. So I can work with them in this project, and they are very helpful. That's what we've done, Bagas and other in our lab. Okay, so next in the next week, I hope that you will use PC for our lesson because uh, I will give you some demonstration using Python, but maybe maybe you already know about Python, but what we do here is using Python to solve engineering problems. So please install. The first assignment is please install the new version of Python in your PC. Okay, and follow the instruction to install the Python in your PC, and we will use uh, this software for the next meeting. Okay.
Okay, sir.
Hmm.
Okay, sir.
Thank you, thank you. So I think it is enough for the introduction of our course here. And sorry, I'm late to introduce myself. So my name is Johannes. I think we already met in the kelas pengantar teknik mesin, right?
Yes.
Yes,
Yes.
sir.
Mhm. So I will not introduce in detail about myself, but if you want or if you interested in the simulation using computer to solve the engineering problem, just visit our lab in Lab Mechanica Benda Padat, Solid Mechanic Laboratory. So we have Mr. Alif Vikarta, which has great competency in mathematics, engineering, engineering mathematics. Uh, so he is very good. I think he is the best among us to derive the equation to predict the failure of the object. So the initiation of crack and how this crack can grow in which direction, you can solve it using mathematics. Yeah, it's very smart. And we also have Mr. Agus Sigit Pramono, uh, which has experience in finite element method. Mr. Juliendra also has work experience in PT Dirgantara. Before joining our department, he was a worker, uh, the main staff of PTDI, PT Dirgantara Indonesia. So he is also good. And we have Mr. Ahmad Saifuddin, which design prosthetic hand on and other biomedic equipment to support the medical rehabilitation. And he is good in composite and other material. Okay, so if you interested at anything about simulation, just visit our lab or send me a message. Okay.
Okay, sir.
Thank you. Okay, so see you next week and bring your PC with you with the Python installed in your PC. Okay, thank you for joining our class and thank you for the discussion. Hope that it can give us many benefits in the future. Okay, see you. Assalamualaikum.
Waalaikumsalam.
Waalaikumsalam.
So,
Sir,
Yes, yes.
I want to ask about the recording. Where do you will send it?
I will post it in our classroom. Okay.
Okay, okay. I see. Thank you, sir.
Thank you,
Okay.
sir.
Okay, I will stop first.